Okay, in this problem, we're going to solve a system consisting of a quadratic equation and a linear equation. The first step is to make sure that we have both equations solved for one of our variables. In this case, we already have both equations solved for y. And the next step is to set these two equations equal to one another. This would be the same as solving a system of equations using substitution. So let's just set these two equal to one another. X squared minus 5x plus 7 equals 2x plus 1. And now we'd like to get this into standard quadratic form. Standard quadratic form is ax squared plus bx plus c equals 0. What that means in practice here is we want to move all these terms on the right side over to the left side and set this entire equation equal to 0. So we can start by subtracting 2x from both sides. Okay. On the right side, 2x minus 2x is 0. On the left side, negative 5x minus 2x is negative 7x. So let's write what we have. This x squared comes down. So we have x squared minus 7x. Bring down the plus 7. And set that equal to 1. Okay, so we'll subtract 1 from both sides now. On the right side, 1 minus 1 is 0. On the left side, 7 minus 1 is 6. That's going to be a positive 6. So let's rewrite. Finally, we have x squared minus 7x plus 6 equals 0. Now from here, to solve the quadratic equation, you could plug this into the quadratic formula, or, and much simpler in this case, would be to factor this equation. So the way that you factor a quadratic is you set up this little template. We have no leading coefficient for the x, so we know that the first term in these factors is going to be x. And now we have to play a little mental game where we try to find two numbers that add to equal one term, and those same two numbers need to multiply to equal another term. So this little template is something that you should set up anytime you have a quadratic equation that has no leading coefficient. This is how you need to set this up. So the terms that they have to add to equal is this middle term right here. This would be the b term in the standard form, and this term is negative 7. Those same two numbers need to multiply to equal 6. So for just a moment, forget about this and just try to solve this little puzzle. Two numbers that add to be negative 7 and multiply to be positive 6. Well, 6 and 1 should be percolating through your mind right now. And the question is it negative 6 and positive 1, or negative 1 and positive 6, or negative 6 and negative 1? Well, negative 6 times negative 1 gives me positive 6, and negative 6 plus negative 1 gives me negative 7. So I write here negative 6 and negative 1, and again negative 6 and negative 1. The order in this little problem doesn't matter. You could have put the -1 first, then the -6. As you see, the arithmetic still works. So now you just take those two numbers with their signs and bring them down here. You just write -6 there and -1 here. We now take these factors and set them equal to 0. X minus 6 equals 0, and x minus 1 equals 0. So just solve these little algebra equations by adding 6 to both sides. Okay, and you get x equals 6. You also add 1 to both sides of this equation, and you get x equals 1. Now, these are not your answers. These are the x values of your answers. In order to find out what the corresponding y values would be, you need to substitute these back into your original equations. And you could substitute them back into either one of your original equations. So this is by far the easier of the two equations. Y equals 2x plus 1. So we are going to evaluate y equals 2x plus 1 at both 6 and 1. Okay, so where x is 6, what is y? Well, y equals 2 times 6 plus 1. Y equals 12 plus 1. Y equals 13. Okay, similarly, we'll do this again, but this time we'll plug in 1 for the x. Y equals 2 times 1 plus 1. So y equals 2 plus 1. Y equals 3. So this is really important. You have to pair the y value that you get with the correct x value. So this 13 that we got goes with the 6. And we list our solutions like this: x, comma, y in parentheses. So our first solution is 6, comma, 13. In other words, when x is 6, y is 13. Similarly, when x is 1, y is 3. So these are the two solutions to this system of equations. Now we can verify that on Desmos by looking to see where these two graphs cross one another. So give me just a moment, or I guess what I'll do is leave this math here in case you're still working on it. Give me just a moment to pull Desmos up on a browser and share that with you so you can see. Okay, so now let me give you a display browser. Okay, so first let's plug in that quadratic equation we had, y equals x squared. And to get the squared, I hold down Shift and hit 6. Shift 6 gives me that squared, minus 5x plus 7. Okay, so over here I see that quadratic graphed. New line, y equals 2x plus 1. So we have to zoom out a little bit until we see both points of intersection. There's one point, 1, 3, and here's another point of intersection, 6, 13. we remember that the point of intersection is the solution to the system of equations. And what I'm trying to do now is make this bigger for the viewer. There. Okay. So there's my two equations. And where they intersect, the green line and the blue line intersect in two places, 1, 3 and 6, 13. Right? So let's get back to our work surface here. So we were able to verify that this system has these two solutions, which we found algebraically. Just as a hint, we know that there will be two solutions because the highest degree, in other words, the highest exponent, is 2. The fundamental theorem of algebra states that whatever the highest exponent is in a system or in an equation, that is the minimum number of solutions that that equation or that system will have. So in this case, the highest exponent is 2. And we know that means fundamental theorem of algebra says there must be two solutions. So this is how you solve a system of equations consisting of both a linear and a quadratic equation using algebra. And we also looked at how you would verify that using graphing software such as Desmos. Finally, this equation here comes from a website called Math is Fun, and I'll just briefly show that website to you so you can see, and I'll include a link in the description. This is a great website. I tell you, I learn a lot of math from this website. So even as a teacher, I'm often visiting Math is Fun. And here's the page, Systems of Linear and Quadratic Equations. Down here, they work this example out for you. So if my method of explaining wasn't clear, you could use this page to try to learn yourself. It's got a lot of interesting stuff, and there's even more problems to work where the equations are not already solved for y. Okay? So I'll include the link to that in the description. Really appreciate your attention for this video. If you found this video helpful, please consider giving the video a like and especially leaving a comment. Comments really boost the visibility of the videos. If you have not already, please consider subscribing to this channel. I do teach math, but this channel is more of a tutoring channel, and I'm here to help anybody. So even if I'm not your teacher, please feel free to leave a comment with a question or some other video you'd like to see, and I'd be more than happy to tailor a tutorial video just for you, free of charge. All right, well, thanks so much for your attention, and you all have a very nice day.